Welcome to chemistry class. Now, let us discuss some examples to consider to get the information, to get the concepts of hybridization VSEPR theory. In previous video, in one video I given how to identify hybridization and VSEPR theory, and one I have explained one example also there. Now let's go for some more examples and how to identify hybridization, shape, number of lone pairs and all these things. In this we can identify shape of molecule and geometry of molecule and lone pairs and bond pairs. We can identify all these things: shape, geometry, lone pairs, bond pairs, all can be identified from this. Or both hybridization and VSEPR theory concept, VSEPR theory, valential electron pair repulsion theory. From this, it is the most core important topic for NEET exam and many competitive examinations. Not only NEET, not only, but for NEET purpose, it is most important lesson. Every time one or two questions, minimum one question is coming from this topic. So if you are perfect in this topic, you will get compulsory one question. To get the perfectness, just practicing one or two molecules is not enough. I'm saying sincerely and seriously, by practicing one or two examples not enough. Minimum you have to practice 10 to 15 examples. Some examples of neutral molecules, some examples of positive ions, some examples for negative ions you have to take, some examples for only bond pairs, some examples which have the lone pairs as well as bond pairs. So you have to divide like that, then you can easily understand how to get that one. Now let me go for the topic. Let me see how to identify the hybridization. I will take one more example. I am taking one example. Example one I am taking, that is best thing is XeF4. I am taking example XeF4. XeF4 I am taking. So how to identify hybridization here, and what is the shape, what is the geometry, what are the lone pairs here, what are the bond pairs here. Let me see now. Not only this example, you can take any example. For all these examples, only procedure is this one. First thing is, first you have to calculate number of hybrid orbitals. Number of hybrid orbitals. That can be calculated by the formula 1 by 2 V plus M minus C plus A we can use. So in this case, V for valence electrons, already in previous video I given that one. Once again, I'm not going to there, but I'm saying here, V for number of valence electrons in the central atom, M for number of atoms which are forming single bonds only, C for charge of cation if it is positive charge, A for charge of anion if it is negative ion. But here it is not negative, here not positive, so at the place of C you have to write 0, at the place of A you have to write it as 0 because it is not ion, it is a molecule, neutral. So only V plus M is enough. Now let me see. V, xenon is the noble gas, means 18th group, it has 8 valence electrons. 18th group elements contain 8 electrons in the valence shell, here it has 8. And 4 fluorines are more electronegative atoms, they can form only one bond, so they are monovalent atoms. You can write that as 4. Minus 0, already I told you it is 0 and it will be 0. Total 8 plus 4, 12. 12 by 2 means 6. So we are getting 6. 6 means 6 hybrid orbitals are present in a sp3d2 hybridization only. sp3d2 hybridization. If 2 hybrid orbitals forming, it is sp3 hybrid orbitals, sp2 4 hybrid orbitals, sp3 or dsp2 5 hybrid orbitals, sp3d 6 hybrid orbitals, sp3d2 7 hybrid orbitals. If you get, that is sp3d3. Here 6 hybrid orbitals we are getting, so it is sp3d2 hybridization. If the hybridization sp3d2, geometry of the molecule is octahedral. geometry of the molecule is octahedral. But here, let me see, geometry becomes a shape when the central atom has only bond pairs, zero lone pairs. But here, let me see, zero lone pairs are there or some lone pairs are there now. Here, 6 hybrid orbitals we are getting. In these 6 hybrid orbitals, only 4 fluorines forming bonds means there are 4 bond pairs only. There are 4 bond pairs only. Remaining in the 6, remaining 2 are lone pairs are present. Once again, I am saying for any molecule you can calculate like this. No exceptions. No exceptions. So all you can calculate 4 bond pairs, 2 lone pairs. Means here lone pairs are there. So lone pairs are means geometry is not octahedral. Geometry is octahedral, shape is not octahedral. According to VSEPR theory, if lone pairs are there, geometry is never becomes equal to shape. So according to VSEPR theory, if 4 bond pairs are 2 lone pairs are there, the shape will be square planar. Square planar. How this square planar we get? Let me see now. First, octahedral geometry I am writing. This is octahedral geometry. Central atom is xenon and 4 fluorines are there. I am writing the position of 4 fluorines like this. You can write anywhere. And 2 lone pairs are there. One lone pair will come here in pure hybrid orbital and another lone pair will become here. So the shape becomes this shape, square planar. These lone pairs do not contribute any shape. So it looks like square. That's why it is square planar will be there. So 4 bond pairs, 2 lone pairs if it is there, the shape is square planar. So shape is square planar, geometry is octahedral, lone pairs are 2, bond pairs are 4, hybridization is sp3 due to VSEPR theory says geometry is not equal to shape or shape is not equal to geometry if it has the lone pairs. So this is an example for hybridization as well as VSEPR theory. And let's go for another example. This is enough. I think if anybody has a doubt in this, please do comment. And if any example you have in any work paper or any book or in any college paper, just do the comment and give the photocopy in the comment. I'll explain in detail for your example. And my request is please share this video to who require the concept of hybridization and VSEPR theory in a simple way, in short way. So reading will not give this much of confidence, this much of information. Listening only will give. So just help them and you will get help from yourself. So by listening all these things and my suggestion and my request, please share. And I'm saying I'm very happy. I'm getting very positive suggestions and positive response from many students and many members. I'm very thankful to you. And if you support like me, I will give a complete and perfect notes for perfect class for any topic or any part of the chemistry. From my knowledge, I can give as much simple as to you. Okay, thank you. Now let's go for another example. Let me take one example of positive charge and one example of negative charge, because how we have to say same concept, lone pairs and all these things. I'm taking one example with the positive charge. You can take any example. Now I'm taking previously asked example. Any positive charge previously asked example is NH4 plus you can take. Let me take NH4 plus ion. What is the hybridization? What is shape? What is geometry? How many lone pairs, how many bond pairs are there in this case? Let us see. Not only this one, you can take any example. You can take any example. Procedure is this only, way is this only. You apply like this, definitely you will get correct answer. Now I'm going to here. Here the central atom is nitrogen. So I'm calculating number of hybrid orbitals. Number of hybrid orbitals equal to 1 by 2 V plus M minus C plus A I'm taking. So 1 by 2. Nitrogen is the central atom. valence electrons are 5 will be there. I am writing here. Hydrogen can form only bond, one bond, that is single bond. So they are 4 in number, minus it has positive charge, means 1, no negative charge, so 0. So 4 minus 1, 3 plus 5, 8. 8 by 2 equal to 4. Here we are getting 4 value. 4 means hybridization will be sp3 hybridization. Here we are getting sp3 hybridization. If the hybridization is sp3, geometry is tetrahedral. Th you can write. That is full form is tetrahedral. Let me see, is this shape or not? Is this geometry shape or not? Let me see. I already told you, if central atom does not have any lone pairs, geometry becomes shape. So here 4 are there. So 4 hydrogens form 4 bond pairs. 4 hydrogens form 4 bond pairs. No lone pairs means 0 lone pairs. Here 0 lone pairs. No lone pairs are there. So geometry equal to shape. The tetrahedral shape will be there for this molecule, because the central atom does not have lone pairs, only it has bond pairs. So if the central atom has only bond pair, we can say that that molecule as symmetrical molecule. Please remember, if it has only bond pairs around it, no lone pairs, symmetrical molecule. Generally, the dipole moment for these molecules will be 0. Mu means dipole moment. For symmetrical molecules, dipole moment will be 0. This is, the shape is tetrahedral, geometry also tetrahedral, lone pair 0, bond pair 0, hybridization sp3. According to VSEPR theory, if no lone pairs, geometry equal to shape. This is one example, and another example here itself I will take. Another example here I will take. One more example for anion NO3 minus I will take. You can take any other examples also, no need to consider this only. So I'm getting this idea. So you can say any example. I'll make a separate video for that examples if you want. If you are not getting the same like this hybridization, and if you are getting wrong answer, just give that molecule to me. I'll explain, and your comment is important. Are you getting this concept, and are you getting the answer by this concept or not? Okay, now let's go for anion. In this case also, let me calculate first number of hybrid orbitals. Number of hybrid orbitals. So same formula, 1 by 2 V plus M minus C plus A we can write. So in this case, central atom is nitrogen. Nitrogen valence electrons 5 because it belongs to 15th group element. Its valence is 5. Now M means number of monovalent atoms. Here oxygen is there. Oxygen never forms single bonds. It forms 2 bonds. Maybe it is double bond or 2 single bonds. Oxygen forms 2 bonds because its valence is 2. So it forms 2 bonds, that may be double bond or 2 single bonds like this. Center oxygen will be there, here 1 bond, here 1 bond with certain angle because it has 2 lone pairs. So 0, because it is not single bond atom. It do not form single bonds. It is not monovalent atom. It is divalent atom. So 0. No positive charge, so 0. It has a negative charge, so plus 1. Anion amount of negative charge is 1 is there, so plus 1. If I write 5 plus 0 minus 0 means 6 by 2 means 3 we are getting here. If it is 3, hybridization will be sp2 hybridization. sp2 hybridization are there. Now in this there are 3 oxygens form. Each oxygen form 1 sigma bond and 1 pi bond. So pi bond never contribute any shape. Remember, pi bond never contributes shape. Why? Because it is parallel to sigma bond. Suppose this is sigma bond, pi bond will be there parallel. So it never present in a separate angle. So parallel to that one. So never contribute any shape this pi bond. Only sigma bonds will contribute the shape. Each oxygen form 1 sigma bond, 1 pi bond. So there are 3 sigma bonds, 3 pi bonds. The 3 sigma bonds form 3 bond pairs. Actually 6 bond pairs are there. Remember, 6 bond pairs are here, but pi bonds we should not consider for shape. So 3 sigma bonds only we have to consider. That's why I'm writing there are 3 bond pairs, no lone pairs. Why? Because here 3 only we are getting, 0 lone pairs. If 0 lone pairs are there, geometry equal to shape. So for sp2 hybridization, geometry equal to shape. That shape and geometry is trigonal planar. Trigonal planar. So NO3 molecule shape is trigonal planar. The shape of NO3 is trigonal planar. Geometry of NO3 minus is trigonal planar. Lone pairs of NO3 minus is 0. Bond pairs of NO3 minus is 3. Hybridization of NO3 minus is sp2. According to VSEPR theory, if 0 lone pairs are there, geometry is equal to shape. Like that, you can identify shape and hybridization for any molecule. Once again, I am saying this is the main formula, number of hybrid orbitals. Number of hybrid orbitals, and here also same I have used number of hybrid orbitals. Based on that you can identify hybridization, based on that you can say geometry, and after identifying bond pairs and lone pairs you can identify shape. If lone pairs are 0, geometry is equal to shape. If lone pairs are there, based on the number of lone pairs and bond pairs, the shape will be there. So this is VSEPR theory and these examples. By using this concept, you can write any example, shape, geometry, lone pairs, bond pairs, hybridization, and VSEPR theory concept. All these things will be covered within just formula. And I have explained 3 examples only in this concept. That 3 examples only are not enough. Genuinely I am saying not enough. For this, add 12 more examples. It will become 15. So you will get complete idea about hybridization, VSEPR theory. Don't take same examples, same hybridization example. Try to use different hybridization examples. In previous NEET papers, in previous exam papers, if you search the books, you will get many examples, and every day those who are writing and every weekend those are writing NEET exam and all competitive examinations, you can take any example and you can practice based on this concept. You will get complete idea about hybridization and VSEPR theory. Thank you. Please share this video to needy people, those who require and those who didn't understand during their class timings and their lecturers classes, so they can easily understand and revise one more time if you are not understanding one time. My best suggestion, revise. If you are not understanding, revise one more time, you will get basic idea. But I'm saying before practicing this example, go before this video. One more video was there before to this video. Go there and I have explained how to identify all these things. Then come from this, for this, practice these 3 examples. Addition to this, practice 12 more examples. It will take hardly half an hour. So you will get complete idea about this topic. So you will get the answer. Please do comment if any things are there, and please don't hesitate anything to say. And if any wrong is there, I think I'm not saying any wrong concept here. If anything is there, please say. Thank you.